So I saw in the news recently that there's a proposal for a mission to go back to a comet and actually return a sample from it, which is pretty amazing.
Yeah, comets are relatively nearby things that, humans can actually send stuff to and maybe even send people to in the not too distant future.
Yeah, so very different to what either of us do, things that are way, way too far away to ever actually go and visit. This is pretty cool. So I'm excited to talk to someone who actually knows more about this. We have with us today from Goddard Space Flight Center, Dr. Adam McKay. Welcome, Adam.
Thank you for having me.
All right, Adam. So give us a little bit of maybe history about, comets. This is one of the big things that people in like the 1800s were obsessed with finding, right? And, just what are comets? What are they actually?
Yeah, so what a comet actually is a small body, at least small astronomically speaking. Obviously, there's probably, most of the people you talk on the show are talking about stars and galaxies, and comets are much smaller than that, miles across. And they orbit the sun. And what kind of makes them really cool, at least from my point of view, is that they have a lot of ices on them. And when these ices get really close to the sun, they heat up and they can sublimate and release and kind of form these nice gas coma and tails and stuff that comets are so famous for.
So you talked about ices on these being, interesting. So is this like water, ice, frozen water that I can get out of my freezer? Is it other frozen stuff or, combinations of things, I'm guessing?
Yeah, so it's actually mostly water ice, like you would find in your freezer. So about 80% of the ice is water ice. So you also have a lot of carbon dioxide ice, so dry ice, if you've ever played with that, dry ice as well. And then smaller amounts of things like carbon monoxide, methane, ethane, and all sorts of nice organic molecules.
So, what is it that you learn by studying the kind of compounds and things that you find on comets?
Yeah. So what makes comets so special is, they form 4.6 billion years ago when the solar system's forming. They're kind of small, cold, and then they just kind of they interact with Jupiter and Saturn and all the other planets, and they get thrown out way into the outer reaches, the really cold areas of the outer solar system. And they just sit there for 4.6 billion years. They don't heat up. They don't really, very minimal processing of their composition. So when they come back in and we can observe them today, we can kind of use them as fossils to help understand what the physics and chemistry was like when the planets were forming. So you can kind of think about comets as our dinosaur bones.
All right, dinosaur bones in space. That seems reasonable.
That sounds pretty awesome. Um, so I've read before that there's a theory that the water on Earth may have been delivered by comets. Is that true?
That's still for debate. So the way we're trying to test this is by measuring the deuterium abundance in water. So deuterium is just kind of a heavy variant of hydrogen. And by measuring that abundance in water and comparing it to the abundance we see in our Earth's oceans, we can try to understand where the water came from. So we have done this for a number of comets. Very early on, a lot of them had too much deuterium compared to the Earth's oceans. So it kind of fell out of favor a little bit, but more recently we found a couple of comets that are closer to the Earth's value. So that kind of reinvigorated the idea. And then Rosetta at their comet found one of the highest deuterium abundances we ever saw. So it's still very much in debate. Right now, it's probably not comets, maybe something more like asteroids or meteorites kind of brought the water to Earth, but it's still an ongoing debate.
So Rosetta was this pretty famous spacecraft. It got quite a lot of coverage when it was doing its thing, looking at a comet, observing on a comet, landing a chunk of itself onto the comet, looking for this heavy water deuterium stuff. Could you go into a little bit about what that mission did and what it found?
So we've had sent missions before to comets to do flybys, so very quick, few hours, kind of study what you can and then move on. This was the first chance to do an actual orbiter that would stay around a comet long term and follow it throughout its orbit around the sun. And so it arrived there in the summer of 2014 and stayed in orbit for about 2 years, imaging the surface, studying the geology, studying the composition of the gases that were coming off. And as also said, one of the most newsworthy things was also it was the first attempt at landing a spacecraft on a comet, a lander called Philae, which got a lot of press. The landing didn't go quite as planned. It was, you usually like to have things land once. It landed 3 times, but eventually it settled down and was able to get some good science.
Very good, very good.
So the thing that I want to know the most is I've seen the movie Deep Impact, my favourite of the late 90s space disaster movies.
Which is an incorrect statement.
True statement. True statement. The science is better than Armageddon. Come on, it's a low bar.
Fine.
So how likely is it that Deep Impact could happen? Are we in danger from a comet smashing into the Earth?
Not any in the foreseeable future. Though the risk of impacts from comets and asteroids is certainly real. I mean, there's definitely a history of impacts on the Earth. I mean, probably the most recent one, right, was the one that killed the dinosaurs. Still debated whether that's actually an asteroid or a comet that did that. But still, we do have these large impacts. They're very rare, though. And so hopefully that's why we have survey programs that are trying to search the sky for anything that could come close and potentially do harm.
So what's the next step in comet research? And what are you really excited about on the few-year timescale?
Yeah, so the next step is to actually try to bring a sample of a comet back to Earth. Now, we did this in the 2000s with the Stardust mission, but that was one where they flew through the tail of the comet and collected dust particles, and they brought those dust particles to Earth. But the problem with that is you only get the dust particles as kind of refractory silicon-rich material, whereas we would really like to bring back these ices if we can. So actually in this last call for NASA missions, so it's called New Frontiers class, which is kind of a middling expense class of mission, there were actually 3 different comet sample return missions that were submitted. One called Caesar was selected to be a finalist for this call. So it's competing against a Titan mission. So one of those 2 missions will be the next New Frontiers mission done by NASA. And we are hoping that Caesar gets selected so we can get a sample return from a comet.
Any idea when NASA's supposed to finalize that decision?
Finalizing it probably within the next year, 6 months to a year. That's usually kind of the time scale for this. Yeah. So for the sample, I think the time scale for the sample to get to Earth is like 2038. So
okay, good to know.
So don't hold your breath trying to get some comet ice. Or when I spoke at Astronomy and Tap DC a few weeks ago, they were hoping to have some ice to put in their drinks from a comet. And I said, don't hold your breath.
Astronomy on Taps around the world will continue long into the 2050s and beyond, I'm sure. So.
I did say that there was ethanol in comets as well.
Of course.
And they were hoping they could have ethanol vodka or vodka made from alcohol from a comet. And again.
All right. Well, thanks, Adam. We appreciate you being on, and we'll definitely maybe not hold our breath for our space ice, but that would be fun to look forward to in maybe, a couple of decades. So cheers. Thanks for coming out for us.
Yes. Thanks you for having me.